pinhole leaks in domestic water lines, with 90% occurring in hot water lines and 10% in cold water lines, can stem from several underlying issues. The fact that a main grounding electrode is carrying 3.50 amps from the main distribution panel to building steel, coupled with equipment grounds carrying 3.5 amps to 7 amps to transformers, subpanels, and equipment, strongly suggests electrical involvement. Electrolytic corrosion is one possible cause. This arises when dissimilar metals are present in the water system. These dissimilar metals create an electrical current, leading to pitting and corrosion. The presence of copper from heating elements or brass fittings in the hot water line can exacerbate this issue. Stray currents represent another potential culprit. Stray electrical currents from external equipment or facilities can infiltrate the water system through ground faults or improper wiring. These currents initiate electrolysis, which significantly accelerates corrosion. Elevated water temperatures can also contribute to the problem. Excessive hot water temperatures can weaken the metal pipe walls, making them vulnerable to pinholes due to pressure fluctuations. Chemical imbalances in the water supply are another factor to consider. Imbalances, such as high acidity or low alkalinity, intensify corrosion rates. The amperage readings on the main grounding electrode, equipment grounds, and transformers suggest the presence of significant ground fault currents. These currents can flow through the water system if the piping lacks proper grounding or if there are breaks in the ground wire. These ground fault currents establish potential differences between the water pipe and the surrounding environment, thus promoting electrolytic corrosion. To address this multifaceted issue, a series of diagnostic and corrective measures is needed. Firstly, test for stray currents. Employ a clamp-on ammeter to meticulously check for stray currents in the water pipe and other exposed metal surfaces. Secondly, inspect the grounding system. Verify that the main grounding electrode is correctly installed and demonstrates a low resistance to earth. Carefully examine all equipment grounding conductors for any signs of damage or breaks. Thirdly, measure voltage differences. Utilize a voltmeter to measure potential differences between the water pipe and surrounding metal surfaces. Any notable voltage readings are indicative of a ground fault. Addressing electrolytic corrosion requires specific actions. Firstly, remove or replace dissimilar metals that are in contact with the water system. Secondly, consider using a sacrificial anode to safeguard metal components. Controlling water chemistry is also essential. Adjust the pH and alkalinity of the water to mitigate corrosion rates. Moreover, inspect for high temperatures. Check the temperature of the hot water line and contemplate installing a mixing valve to regulate the temperature effectively. Installing a dielectric union can isolate the hot water tank from the water line, reducing the risk of electrolytic corrosion. To elaborate on testing for stray currents, a clamp-on ammeter is a valuable tool. This device allows you to measure the current flowing through a conductor without physically disconnecting it. When testing the water pipe, place the ammeter around the pipe and observe the reading. Any significant current flow indicates a potential source of stray current. Repeat this test on other exposed metal surfaces near the water system to identify the source of the current. Regarding the inspection of the grounding system, the main grounding electrode plays a critical role in providing a path for fault currents to return to the source. It is essential to ensure that this electrode is properly installed and has a low resistance to earth. A ground resistance tester can be used to measure the resistance of the grounding electrode. A low resistance reading, typically below 25 ohms, indicates a good ground connection. Inspect all equipment grounding conductors for any signs of damage or breaks. These conductors provide a path for fault currents to flow back to the source, protecting equipment and personnel from electrical shock. Look for loose connections, corroded wires, or any other signs of damage that could compromise the integrity of the grounding system. When measuring voltage differences, a voltmeter is used to measure the potential difference between 2 points. In this case, the voltmeter is used to measure the potential difference between the water pipe and surrounding metal surfaces. Any significant voltage reading, typically above 0.5 volts, indicates a potential ground fault. This voltage difference can drive electrolytic corrosion, accelerating the deterioration of the water pipe. Addressing electrolytic corrosion involves removing or replacing dissimilar metals that are in contact with the water system. Dissimilar metals create a galvanic cell, where one metal corrodes preferentially to the other. Replacing these dissimilar metals with compatible materials can significantly reduce the risk of electrolytic corrosion. A sacrificial anode is a metal that is more easily corroded than the metal it is protecting. The sacrificial anode is placed in contact with the metal component that needs protection, and it corrodes instead of the component. This provides a cost-effective way to protect metal components from corrosion. Controlling water chemistry is crucial in preventing corrosion. The pH of water is a measure of its acidity or alkalinity. Water with a low pH is acidic and can corrode metal pipes. Water with a high pH is alkaline and can also cause corrosion. The ideal pH range for drinking water is between 6.5 and 8.5. The alkalinity of water is a measure of its ability to neutralize acids. Water with low alkalinity is more susceptible to corrosion. The ideal alkalinity range for drinking water is between 30 and 500 mg per liter as calcium carbonate. Adjusting the pH and alkalinity of the water can significantly reduce corrosion rates. Inspecting for high temperatures is also necessary. Excessive hot water temperatures can weaken the metal pipe walls, making them more susceptible to pinholes from pressure fluctuations. Check the temperature of the hot water line and consider installing a mixing valve to regulate the temperature effectively. A mixing valve blends hot and cold water to maintain a consistent water temperature, preventing overheating and reducing the risk of pipe damage. Finally, installing a dielectric union can isolate the hot water tank from the water line, reducing the risk of electrolytic corrosion. A dielectric union is a fitting that electrically isolates two dissimilar metals, preventing the flow of electrical current between them. This can significantly reduce the risk of electrolytic corrosion in the water system. Remember to adhere to all local and national electrical codes, especially the National Electrical Code, or NEC. Article 250 covers grounding and bonding requirements for electrical systems. Proper grounding and bonding are essential for preventing electrical shock and minimizing the risk of stray currents that can cause corrosion. Additionally, understanding the chemical composition of the water is key. Contacting the local water authority for a detailed water analysis report could provide further insights into potential chemical imbalances that might be contributing to the corrosion process. This report will outline the levels of various minerals and chemicals, helping determine if adjustments to the water chemistry are needed. Consider a comprehensive inspection of the entire plumbing system, not just the hot water lines. Check cold water lines, fittings, and connections for any signs of corrosion or damage. Look for any unusual discoloration, pitting, or scaling on the pipes. Furthermore, explore the possibility of galvanic corrosion due to dissimilar metals used throughout the plumbing system. Check the connections between different types of pipes, such as copper and galvanized steel, as these junctions are particularly susceptible to corrosion. Implementing a preventative maintenance program can help identify and address potential problems before they escalate. Regularly inspect the plumbing system for any signs of corrosion or damage. Flush the hot water tank periodically to remove sediment and mineral buildup. Consider installing a water softener to reduce the mineral content of the water, especially if the water is hard. Also, it's worth investigating the possibility of induced currents from nearby power lines or electrical equipment. If the water pipes are located near high-voltage power lines or electrical equipment, stray currents could be induced in the pipes, contributing to corrosion. Shielding the pipes or rerouting them away from the source of the induced currents can help mitigate this problem. If the problem persists despite these measures, consulting with a qualified plumbing contractor or corrosion specialist is advisable. These professionals have the expertise and equipment to diagnose the problem accurately and recommend the most effective solution. Also, remember to document all inspections, tests, and repairs. This documentation will provide a valuable record of the plumbing system's condition and any maintenance performed. This information can be helpful in identifying trends, tracking down problems, and making informed decisions about future repairs or upgrades. This is especially important for commercial properties like motels, where maintaining a safe and reliable water system is essential for the well-being of guests. Remember safety first when dealing with electrical and plumbing systems. Always disconnect power before working on electrical components and turn off the water supply before working on plumbing. If you are not comfortable working on these systems, consult with a qualified professional. In addition to the NEC, other relevant codes and standards may apply. Check with the local building department to determine the applicable codes and standards for your area. Adhering to these codes and standards will ensure that the plumbing and electrical systems are installed and maintained safely and correctly. Finally, stay informed about the latest developments in plumbing and electrical technology. New products and techniques are constantly being developed to improve the performance and reliability of these systems. Staying up to date on these developments can help improve the plumbing and electrical system's efficiency and longevity. By following these recommendations, you can effectively address the issue of pinhole leaks in domestic water lines, protect the plumbing system, and ensure water quality. Regular maintenance and inspections can help prevent future problems and ensure a safe and reliable water supply. Remember to consult with qualified professionals if you are not comfortable performing these tasks yourself. By taking these steps, you can ensure that the plumbing system is operating at its best and that guests have access to safe and reliable water. Moreover, consider the age of the plumbing system. Older plumbing systems are more susceptible to corrosion and other problems. If the plumbing system is more than 20 years old, it may be time to consider replacing it. Replacing the plumbing system can be a significant investment, but it can also save money in the long run by reducing the risk of leaks and other problems. Furthermore, evaluate the water pressure in the plumbing system. High water pressure can put stress on the pipes and fittings, increasing the risk of leaks and other problems. If the water pressure is too high, consider installing a pressure-reducing valve to lower the pressure to a safe level. Also, think about the pipe material and its compatibility with the water chemistry. Certain pipe materials are more resistant to corrosion than others. Consider replacing the existing pipes with a more corrosion-resistant material, such as PX or CPVC. These materials are also more flexible than copper pipes, making them easier to install and less prone to leaks. It is also important to inspect the water heater regularly. The water heater is a critical component of the hot water system, and it is susceptible to corrosion and sediment buildup. Regularly flushing the water heater can help remove sediment and prevent corrosion. Consider installing a water heater with a corrosion-resistant lining, such as glass or ceramic. Also, think about the use of electronic water conditioners, which are devices that use electrical or magnetic fields to alter the properties of water. These devices are claimed to reduce scale buildup and prevent corrosion. While the effectiveness of electronic water conditioners is debated, some studies suggest that they can be beneficial in certain situations. You can also explore the option of using corrosion inhibitors, which are chemicals added to water to reduce the rate of corrosion. These inhibitors work by forming a protective layer on the metal surface, preventing corrosion. However, it is important to carefully select corrosion inhibitors that are compatible with the plumbing system and the water supply. Furthermore, consider implementing a water conservation program. Water conservation not only saves money but also reduces the demand on the plumbing system. Install low-flow shower heads and toilets, and encourage guests to conserve water. A well-designed water conservation program can significantly reduce water consumption and extend the life of the plumbing system. In addition to the above, you can also consider the use of a plumbing camera to inspect the inside of the pipes. A plumbing camera is a small camera that can be inserted into the pipes to inspect for corrosion, leaks, and other problems. This can be a valuable tool for identifying problems that are not visible from the outside. Always ensure that the plumbing and electrical systems are properly maintained and inspected regularly. Regular maintenance and inspections can help identify and address potential problems before they escalate, saving money and preventing costly repairs. Consider hiring a qualified professional to perform regular maintenance and inspections. This is just more to think about when addressing and maintaining a commercial property's water system and corrosion issues.